Hey guys, back here going to be doing a Stoichio lab challenge using a rather um, old experiment that you guys probably grew up on with the baking soda and vinegar. And you got those little science fairs where you make sort of like those volcanoes and they'd fizz and bubble and pour over the sides. Well, hopefully this doesn't pour over the side based off how much I use, but it's an old science trick and it's definitely entertaining at various ages. But we're going to be more mindful about some chemical products we get rather than the effects. And so what I'm going to do here for you is I'm going to measure out 5 grams of the sodium bicarbonate, which is baking soda. And then we have vinegar, kind of. The active ingredient in vinegar is acetic acid. And this is a lab grade acetic acid solution. Okay. And it's 2 molar, and I'm going to measure out 250 milliliters of that. And we'll be able to figure out some of the mole information here, and using some Stoich, I'll be able to calculate how much carbon dioxide can come off. It also makes what's known as sodium acetate, which I tried to purify one time to get some seasoning from, but it didn't exactly work out for me. But oh well, that should be what's be. So I got my Vader lab assistant. So what I'm going to do is measure out this 5 grams of sodium bicarbonate using my balance back here. Push to 0. Okay. I got some sodium bicarb in here because the jug's pretty big to fit down into there. So I'm going to go ahead and measure this out. Okay, so we get 5 grams of this. Okay. Oops. A little bit over. It's reading 5.1. Okay, a little bit up. 5.0. There we go. 5.0. Okay, so we got my sodium bicarbonate there. Okay. NaHCO3. So this is 5 grams there. Okay. And what I'm going to do is I'm going to add my 5 grams eventually to this container. But what I want to do first is go ahead and put 250 milliliters of acetic acid in here. So acetic acid, the purified form, if you love vinegar smell, acetic acid just makes the mouth water, in my opinion. So I'm going to carefully add 250, okay, to my flask here by using a 100 milliliter graduated cylinder here. So I'm going to have to fill this a couple of times and get it down to eye level. Nice, refreshing vinegar smell. Okay. So try to add it as precisely as I can. So we've got 100 there. That's 100. Okay, fill it up again. So I want 250. I used to open bottles of glacial acetic acid in college just to smell the stuff. Vinegar. So this is 200. 50 more, and then we'll be exactly where we need to be. Okay. Have out a few of them bubbles, a little bit more required, just a splash. Looks to be about right. So this is much stronger than regular vinegar, mind you, because this is the purified stuff, acetic acid. And so what we're going to want to do, okay. Whoa, Nelly. Okay, I'm going to set that aside because I'm done with it. Got my acetic acid here. Now I'm going to weigh it. Okay, make sure I hit 0 again. And this mass is going to be important because we're going to want to compare mass of reactants and mass of products. Overall, we're looking at the the total mass of the reaction. And remember, law of conservation of mass says, okay, mass is neither created nor destroyed in a chemical reaction. Okay, ooh, 436.8. So the flask, I'll be mindful here. The flask with the acetic acid equals 436.8 grams. Okay, so flask before, okay, with the acetic acid, 436.8 grams. We're going to keep that in mind. We'll revisit that here in a moment. Now, these are my initial setups. Push you over there a little bit. So we got 5 grams of my baking soda here, sodium bicarbonate. I'm going to add to my reaction vessel. And we measured out 250 milliliters of 2.0 molar acetic acid. So what I'm going to do, and I'm going to do this as entertaining as possible because I was going to decorate this look like a volcano, but it's sort of already natural. It looks that way. Okay. So we're going to do, I'm going to carefully add to this container. I'll put my little dinosaur there, like, you know, Jurassic. The Jurassic period, folks. Zoom in. I'm not going to do this really, really fast because I'm going to try not to have it spill over because that would be bad for my results. And so I'm going to gently add this. And when we're doing it, we're going to get the reaction of baking soda and vinegar, or sodium bicarbonate and acetic acid. And you're going to get a reaction and you're going to be making some products. And we're going to figure out how much CO2 comes off this reaction. Okay. So I'm going to carefully add. Ooh. No. Stop. Oh, okay, good. Oh. Had me worried there in the first half. Delightful smell. It's going to take some time to react. It's fizzing and bubbling there. Bubbling and fizzing. Ah. Guys can see it. Run for your lives. Okay. Okay. Still bubbling. Still bubbling. Still bubbling. So when you're looking at this, it's an acid-base reaction. Sodium bicarbonate functions as your base, and the acetic acid naturally is acid. And so when you have an acid-base reaction, which is a special type we'll study here in a little bit, you make various substances. One of them is usually a salt. And then another's typically water, but be mindful of the balanced chemical equation that you're going to see in the lab form itself. So got our little bubbles here. I'm going to try to tap as many away as possible. Okay. Because we've made product. Okay, and I just want to make sure. Okay. Numbers work out. So there we go. It's looking pretty good and thoroughly reacted. And I could, of course, add more baking soda, but that's not really the point. I just want to remind you that the flask before with the acetic acid in it was 436.8, okay? 436.8. I added the 5 grams. I added the 5 grams of baking soda, right? So keep this in mind too. So let me zoom out just briefly. Look at that. So I added 5 grams of baking soda. That's the baking soda down there. So you would want to look at those being the masses before. And we need to figure out the mass of CO2. Now the mass of CO2 given off, we're going to assume all the carbon dioxide left the container. Okay, because it's a gas. Gases like to rise. Okay, so the CO2 should have left the container, leaving the other product behind. and any other unreacted substances from the reactants. So let's go ahead and look at what the mass is with the baking soda in it. Okay, see if I can, the glare. Okay, so I can somewhat see that 0.0. Hopefully you guys can, but if not, we'll try to zoom it in there. Okay, so I'm gonna put the flask back on here. Okay, and right now, okay, let me try to orient it so it's not, that says 439.7.8. It's fluctuating there, so keep that in mind. That is a number we need to keep in mind. So running out of room here. So let me go ahead. So record 439 point, up and went up, 439.8. So so zoom. Okay. So it's fluctuating, but the balance is reading 439.8 grams. So we combined, okay, our substance is down here. So you want to combine those masses and compare that to this 439.8. With that information, you should be able to discern and determine the mass of CO2 that had been generated. Okay, so we can do some Stoichio here and compare theoretically how much CO2 we should have gotten out of this reaction to how much was actually produced, and do some analysis with that. Okay, so we're gonna figure out some Stoichio stuff, okay, using this good old-fashioned reaction. Okay, so as usual, as questions arise, send them my way, and we got this. Okay, we'll figure out some data. See you in a bit.